In this lesson, we are going to learn how to dilate a parabola. So, by the end of the lesson, you should understand the process of dilating a parabola. You should know how to describe dilation of a parabola, apply dilations to quadratic functions, and observe the graphical effects. You should identify the critical features of a dilated parabola and sketch the dilated parabola given the different forms of the quadratic equations. Just a quick recap. The three forms of quadratic equation: the general form, the root form, and the turning point form. So far, we have looked at the situation when a equals to 1, which is a monic quadratic equation. This time, we are going to look at a possibility greater than 1 and less than 1. And remember, a is never equals to 0. Alright? So, the basic parabola. You know that it is a concave up shape and the axis of symmetry is x equals to 0. The turning point is at the origin. Right? So from there, you know how to translate the parabola up and down, left or right, or a combination of both. You've also learned how to reflect the parabola, which is upside down parabola or concave down, or what I normally call it the N shape. And then you have also learned how to translate the reflected parabola. Now, just graphically, let me illustrate. So here, vertical translation, you've reflected y equals to x squared up and down. Horizontal, left and right. Note that all these parabola, the translated parabola, are congruent to the basic parabola. So, if you actually move x minus 4 across back to y equals to x squared, it covers it. So therefore it is called congruent. They are exactly the same shape. This is the reflection. Y equals to minus x squared is a reflection of y equals to x squared. Again, y equals to minus x squared is actually congruent to y equals to x squared, because when you flip y equals to minus x squared around, it will cover y equals to x squared. So again, you've learned how to translate y equals to minus x squared. Alright? I would now like you to take out your class pad. Plot the three different parabola. Alright, see if you can get the same graph as me. Alright, here you know that the blue line is y equals to x squared. The red line is y equals to 2x squared. And the green line is y equals to half x squared. Alright? In your mind, think about what happened when this in fact is y equals to ax squared. So when a is 2, what happened to the parabola? And when a is half, what happened to the parabola? Think about it first. Let's go on to the next one. Here you can see that the red is actually narrower than the y equals to x squared. And the green line here is wider than y equals to x squared. Here again, use your class pad. Plot y equals to minus x squared, y equals to minus 2x squared, and y equals to half x squared. Alright? Here, this line, y, the red line is y equals to 2x squared. The green line is y equals to half minus half x squared. This is minus 2x squared. Alright, let me write it out a bit better. Y equals to minus half x squared. Alright, think about it again. What happened to the shape when you've got a as minus 2 or a as minus half? Alright, now Go back one slide. Then, same with this. Y equals to minus 2x squared is narrower than y equals to x squared. Y equals to minus half x squared is wider than y equals to minus x squared. So what is it telling me? Y equals to ax squared is actually a dilation of y equals to x squared. So for a greater than 0, the parabola is narrower than the basic parabola. For a is greater than 0 but less than 1, the parabola is wider than the basic parabola. Alright? Now, when you've got a equals to minus 1, this is the reflection of the basic parabola, the upside down parabola. And when a is greater than minus 1, say it's minus 2, minus 3, minus 4, the parabola is narrower than the basic parabola. And for 0 less than a less than minus 1, the parabola is wider than the basic upside down parabola. Okay. Let's have a quick look at the key features of a quadratic function again. This time, the most important thing here is a. Alright? It gives you the dilation factor. It's either narrower or wider than the basic parabola. Again, positive implies concave up, which is the U shape. And then negative implies concave down, the N shape. Of course, you need to know the axis of symmetry, the turning point, maximum or minimum. In this case, I'm showing an upside down parabola, so it's a maximum. You need to know the x-axis intercept, which is the roots, and then the y-axis intercept. Right, let's start now by sketching some parabola. So let's have a look at y equals to 2 into x plus 2, x minus 3. First, we know the roots. Let's work out the roots. So that is x-intercept. Okay? When y equals to 0, 0 equals to 2, x plus 2, x minus 3. Therefore, x equals to minus 2 or plus 3. So the two roots are minus 2, 0, and 3, 0. Alright? So then, next bit, we work out the axis of symmetry. Is x equals to 2 plus minus 3 divided by 2, which is minus 1 divided by 2. So x equals to minus half. Next, let's find the turning point. Substituting x equals to minus half into the equation, y equals to 2, minus half plus 2, half, minus 3. That is 2 minus half plus 2 is 3 over 2. That's 1.5 actually. And then minus half plus minus half minus 3 is minus 7 over 2. So then we can cross that out. 3 times 7 is minus 21 over 2. So the turning point is minus half minus 21 over 2. Alright? And we know that this is the minimum turning point because this is a concave up shape. Alright, so we now know the roots, we now know the turning point, now know the axis of symmetry. The other thing we need to look at is the y-intercept. This is when x equals to 0. So y equals to 2, 2 and minus 3. 2 times 2 is 4, 4 times minus 3 is minus 12. So so the y-intercept is 0, minus 12. Alright, let's start sketching it. So we know the axis of symmetry is x equals to minus half. X equals to minus half. Alright? And then you know the turning point is minus half minus 21 over 2. So let's say somewhere around here. Minus half minus 21 over 2. And then since we know that it is concave up, we could actually sketch this first. And we know that that would be minus 2 and 0. That is minus 3. That is plus 3, 0. And this point is 0, minus 12. And this is y equals to 2, x plus 2, x minus 3. Right. So this is how you actually sketch a dilated parabola. Right. Let's try to sketch this one. Here, you know that this is actually a concave down parabola since the coefficient here is minus 4. Alright, so we know that shape, concave down. Now, start off with the roots. So you know that the root would be 5, 0 and minus 3, 0. Alright, you can write it down straight away because you know the null factor law. Alright, so here we know the axis of symmetry is actually x equals to 5 plus minus 3 over 2, which is 5 plus minus 3 is 2 over 2 is x equals to 1. Substituting turning point, substituting x equals to 1, so y equals to minus 4, 1 minus 5, 1 plus 3, that is minus 4, 1 minus 5 is minus 4, 1 plus 3 is 4. So 4 times 4 is minus 4 times minus 4 is 16. 16 times 4 is 64. Alright, so therefore the turning point is 164. Alright, the next bit we need to work out is the y-intercept. Is when x equals to 0. So y equals to minus 4. 0 minus 5 is minus 5. 0 plus 3 is 3. So minus 4 times minus 5 is 20. 20 times 3 is 60. So it's 0, 60. So now, start off with axis of symmetry. X equals to 1. Alright? You know that the turning point here is 164. And the root 1 is 5, 1 is minus 3. So let's say this is 5, 0. And this is minus 3, 0. So I can just sketch this. Oops. And this point is 0, 60. And this is y equals to minus 4, x minus 5, x plus 3. Alright, so it looks almost like a parabola. I don't think I've sketched it that well, but that's fine. As long as you've got a smooth line and you know that the shape is concave down, that will do. Now, what if we are given y equals to ax squared plus bx plus c, the general form? How do we do it? We rewrite the equation as y equals to a, x squared plus b over ax plus c over a. Now, if you can factorize this into something like x plus or minus m, x plus or minus n, do it first. If not, you need to complete the square inside the bracket. Alright, so start off with this. If you can do it this way, x plus or minus m, x plus or minus n, please factorize first. Let's look at a few examples. Start off with this. Y equals to 2x squared minus 2x minus 12. Let's take out the highest common factor, which is 2. X squared minus x minus 6. Well, I'm pretty sure I can actually factorize this because the two numbers which multiplies as minus 6 and add up to be minus 1 is minus 3 and 2. So therefore this is 2x minus 3, x plus 2. Alright, so minus 3 times x plus 2 times x will give you minus x. Minus 3 times plus 2 is minus 6. So therefore, you know this is going to be factorized into this form. Now, from the coefficient, we know the shape is concave up. Alright, the y-intercept, reading from the general form, is 0 minus 12. Alright, then the roots is actually 3, 0, and minus 2, 0. And then the axis of symmetry. X equals to 3 plus minus 2 divided by 2, which is half. And then substitute into the equation to find turning point, because it's concave up, so this is minimum. So you know that y equals to 2, half minus 3, half plus 2, which is 2. Half minus 3 is minus 5 over 2. Half plus 2 is 5 over 2, which is minus 25 over 2. So the turning point is half minus 25 over 2. Alright, we can now sketch the parabola. Let's start off with the axis of symmetry, which is x equals to half. The turning point is half minus 25 over 2. Let's say it's this point, half minus 25 over 2. Alright, the y-intercept is 0 minus 2, and let's somewhere here, and this is your parabola. Y equals to 2, x squared minus 2x minus 12. So that point here is minus 2, 0. This point here is 3, 0. That's all you need to do for sketching. Because there's no scale, you can all approximate and then sketch it. Right, let's have a look at y equals to 2x squared plus 4x plus 9. So here, you know that you can factorize it. So we need to complete the square. To complete the square, let's take the 2 out. X squared plus 4 divided by 2 is 2x plus 9 over 2. Alright? I use a square bracket because it's a little bit easier later. So I've got 2. I've got x squared plus 2x plus 1 minus 1 plus 9 over 2. Alright? Because 1 here is 2 divided by 2 square. So 1 square is 1. So therefore 2 x plus 1 square minus, put a bracket here, 2 minus 9. Therefore it's 2 x plus 1 square 2 minus 1, 9 is minus 7. Minus 7 times minus becomes plus 7 over 2. Multiply the 2 in, so you've got 2x plus 1 square plus 7. Alright, so if I write that down, you can see that this is the turning point form. So starting off with the shape, concave up. Turning point is actually minus 1 plus 7. And then the axis of symmetry is actually x equals to minus 1. And then the y-intercept is actually 0 and 9. Now, you can see that because this is concave out, the turning point here is actually a minimum turning point. Alright? So, because the minimum turning point is actually above the y-axis, you can straight away see that there is no x-intercept. But if you don't believe me, we can actually work out. Check for x-intercept. Alright, so it's y equals to 0. 2 x plus 1 square plus 7 equals to 0. 2 x plus 1 square equals to minus 7 over 2. Alright, continuing up here, x plus, that is already rearranged. I should just get rid of that. So x plus 1 square equals to minus 7 over 2. There's no solution. Therefore, no x-intercept. Alright, we can now sketch. Starting off with the axis of symmetry, x equals to minus 1. Alright, so the y-intercept is 0, 9. And the turning point is minus 1, 7. So this is the parabola. Y equals to 2x squared plus 4x plus 9. Alright, since there's no x-intercept, you cannot indicate it. All you need to do is indicate the y-intercept, the turning point, the axis of symmetry, and the equation. That will do. Alright, what about this? Y equals to minus 2x squared minus 4x minus 6. One thing you can observe from here is this is actually a concave down shape because of the minus in front. So what we can do is take the minus 2 out first. We have x squared plus 2x plus 3. Alright, can we actually factorize this? Not really. So therefore we need to actually complete the square, which is x squared plus 2x plus 1 minus 1 plus 3. That is equal to minus 2 x plus 1 square plus 2. And multiply the minus 2 in, minus 2 x plus 1 square minus 4. Alright, so y is minus 2 x plus 1 square minus 4. So you now know that this is the turning point form. So let's start off with the shape. Concave down. The turning point, minus 1, minus 4. And because concave down, this is the maximum. Alright, so and then the axis of symmetry is actually x equals to minus 1. And then the y-intercept from the general form is 0 minus 6. You know that the turning point is actually maximum and is actually below the x-axis. Therefore, there should be no x-intercept. Let's confirm. X-intercept. When y equals to 0, 0 equals to minus 2, x plus 1 square minus 4. So minus 2, x plus 1 square equals to 4. So x plus 1 square equals to minus 2. So there's no solution. Therefore, there is no x-intercept. Alright, sketching it. Starting off with axis of symmetry, which is x equals to minus 1. Y-intercept is 0 minus 6. And turning point is minus 1 minus 4. Sketching it. This is y equals to minus 2x squared minus 4x minus 6. That's it. Alright, the last one. I would like you to pause the video for a while and actually watch it. Try it by yourself. Right. Again, you can see that there's no way that you could actually factorize this. So let's complete the square. Take the 3 out. X squared plus 2x minus 13 over 3. Therefore, that's 3. X squared plus 2x plus 1 minus 1 minus 13 over 3. That is therefore 3 x plus, oh, there should be 1 here, 1 square minus 16 over 3, and multiplying the 3 in, you therefore have 3 x plus 1 square minus 16. Alright, here you know that the shape is concave up. Alright, because 3 is positive. Next bit, turning point, is actually minus 1 minus 16. Right? You know that because it's concave up, this is a minimum. And then the axis of symmetry is x equals to minus 1. And y-intercept is 0 minus 13. That is from the general form of the equation. So now let's determine the x-intercept. This is when y equals to 0. Therefore 0 equals to 3, x plus 1 square minus 16. 3 x plus 1 square equals to 16. X plus 1 square equals to 16 over 3. Continuing up here, x plus 1 equals to plus or minus 4 over square root of 3, and therefore x equals to minus 1 plus or minus 4 square root of 3. Or you can actually make everything into 3 so that you can rationalize the surds, and therefore you've got minus 3 plus or minus 4 square root of 3. Alright, so here therefore the roots or the x-intercept is minus 3 plus or plus 4 square root of 3 over 3, 0, or minus 3 minus 4 square root of 3 over 3, 0. Alright, so here you can observe that this is actually in the negative x-axis, whereas this bit here is a positive x-axis. Alright, let's start. Starting off with the axis of symmetry. X equals to minus 1. Turning point, minus 1, minus 16. Alright, I'm going to sketch it first, and then indicate the y-intercept, which is 0 minus 13. This point here is 3 plus 4 square root of 3 over 3, 0. This point here is 3, actually minus 3 minus 4 square root of 3 over 3, 0. And finally, we need to label the graph. Y equals to 3x squared plus 6x minus 13. Alright, so you know how to sketch parabola now. A quick summary of the lesson. For sketching a parabola, you know that for general form, you can change it to either root form or the turning point form. General form will actually give us the y-intercept. Alright? The root form will give us the roots or the x-intercept from the root form, the axis of symmetry, and then the turning point by substituting x equals to the axis of symmetry into the equation. The turning point form will give us straight away the turning point and then the axis of symmetry, and then you can work out the roots. Alright, A here just tell us whether it is a narrow or wider. Alright, if it is negative, it is a upside down parabola. So when you graph or sketch a quadratic function, you need to determine the concavity, whether it's concave up or concave down, the axis of symmetry, the turning point, the y-intercept, and the x-intercepts. Alright, this is the end of the lesson.